For our math warm-up today, I would like you to number your board or your paper from 1 to 4 and make each one of these number sentences true. Pause your video. Come on back when you're finished. So if we take a look at each one of these equations, if I place a fraction greater than 1 in this blank, then that's going to make this number sentence true. The same thing is going to happen here if I place a fraction that is less than 1, because notice our symbol this time is 5/8 is going to be the greater one. So we need a fraction less than 1 here. For the third one, we need any fraction equal to 1 because of our symbol here, equal. And the last but not least, we need a fraction greater than 1 because of the greater than symbol here. For our math message today, we're going to take a look at this problem or this statement. You know that 2 4/10 times 1 is equal to 2 4/10. Will 2 4/10 times 1 8/10 be greater than or less than 2 4/10? So first of all, you need to determine if it's going to be greater than or less than, and then I want you to tell me, how do you know that? So go ahead and pause your video and see if you can figure out your answer to those two questions. Okay, so you've had some time to think through this particular problem, or questions, I should say, and I want you to think back to when we were working with multiplying fractions times whole numbers, and when one of our factors was less than 1, like the example here. So this was our whole number. We have a factor that is less than 1. And when we multiplied those, our product was less than one group of 6 because this was our whole number. If we look at the second problem here, this time we're multiplying a whole number times a factor that is greater than 1. So our product is greater than, and the reason is because we have more than one group of 6 for this particular problem. So as you're thinking about our original question up above, will 2 4/10 times 1 8/10 be greater than or less than 2 4/10? Our answer would be greater than because our factors are larger than 1. And so what we need to be thinking about from here on after, if the second factor is less than 1, we know that the product is going to be less than the first factor. If the second factor is greater than 1, we know that the product is going to be greater than the first factor. And what else do we know? If the first factor is less than 1, we know that the product is going to be less than the second factor. And if the first factor is greater than 1, we know that the product is going to be greater than the second factor. So predicting the size of the product is one way that we can make an estimate for multiplication problems. Our lesson today is estimating decimal products and quotients. The reason we are doing this lesson today is we need to be able to make sense of and understand decimal problems. We need to be able to argue and critique reasoning, meaning your reasoning and others. we also need to be able to look for regularity. How we're going to do this today is we are going to use the same reasoning that we used when we were multiplying fractions and apply it. We're going to use similar strategies to make estimates for decimal multiplication and division problems. To begin our practice today, we're going to take a look at several examples where we are going to be estimating. So let's take a look at this first problem. We have 12 and 8/10 times 185 and 3/10. If I were going to estimate this particular problem, I would make that 10 times 200 equals 2,000. Okay, and like I said, this is going to be a process. If we take a look at the second problem, we have 896 and 1/10 times 2 and 7/10. So again, I would take that problem and change that to 900 times 3 is equal to 2,700. If we move to the next one, we have 4 and 1/10 times 0 and 7/10. So we would take this one and make that 4 times 1 equals 4. And the next one, we have 0 and 9/10 times 0 and 3/10. So we're going to make that 1 times 0 and 3/10 equals 0 and 3/10. So there is our first go at making some estimates with some decimal multiplication. Now we're going to take a look at 3 different problems. Up here at the top, we have 110 times 2 and 8/10, 11 times 28 hundredths, and 11 times 2 and 8/10. Which one do you think has a product of 30 and 8/10? So think about how we just went through estimating some problems. If you were going to estimate some of those, which one do you think the answer would be? So if we think through this first problem, we should be thinking that 110 is close to 100 times 3. So this answer is going to be around 300. So that's much greater than 30 and 8/10 that we have up here. If we look here at the second problem, 11 times 28 hundredths, we're going to have a number that is less than 11, but not close to 30 and 8/10, which leaves us with the last problem. If we change this to 10 times 3, this gives us 30. So ding, 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 we have a winner. This would be the most likely choice. That would have an answer of 30 and 8/10. So how do we know where to place the decimal? This is what you're going to be working on in class today. So let's say that we have this division problem here, 82 and 6/10 divided by 7. So the first thing that we want to do is we want to estimate. So if I take 82 and 6/10 and I just round that to 80 divided by 10, I'm going to round that 7 to 10, which equals 8. So when we look at our answer down here is going to have these digits, but we need to decide where's the decimal point going to go. So am I going to put the decimal point here between the 1 and the 1? That's going to be 1 and 18 hundredths. Well, my estimate was 8, so that does not make sense. So am I going to put my decimal point here and make that 11 and 8/10? Well, 11 is pretty close to 8. And would I put the decimal point here after 8, then that would mean my number was 118, and that would be way off. So I believe the logical place to put my decimal would be right here. So now let's take a look at the second problem. We have 12 3/10 times 1 8/10. If we take this problem and we estimate, I am going to do numbers that I can do easily in my head. So I'm going to change 12 3/10 to 10. And we're multiplying times 2. So 1 8/10 I'm going to change to 2. So that gives me about 20. So now when I take a look at, I know that these are the digits in my answer. Where is the decimal point going to go? The most logical place would be right here, between that 2 and that 1, to make my answer 22 1400ths. So let's do a couple more practice problems. Again, we're going to try to figure out where the decimal goes. So our problem here is 53 8/10 divided by 6. So we're going to do our estimating first. And I'm going to make that 50 divided by 10 equals 5. And so now when I look at my answer choice here, I've got lots of digits here. And what makes the most sense is to put my decimal point right here, because 8 and 9, and we're just going to round that to 8 9600ths, would make more sense with my estimate being 5. So I place my decimal point there. We're going to take a look at the next one. We have 9 3/10 times 1 8/10. Again, we're going to do our estimate. So I'm going to make that 10 times 2 equals 20. And then we're going to take a look at our digits in our answer. Would it make sense to be 1 674 thousandths? Nope, I don't think so. Would it make sense to be 16 74 hundredths? Yes. So I'm going to put my decimal point there. So let's summarize what we have done and talked about. We've done lots of practice today, but we learned that we can use similar strategies to multiply and divide decimals that we use when multiplying fractions. Digits can be the same and in the same order, but decimal points can be in different places dependent upon our factors. Making estimates is a very important strategy to use in determining the reasonableness of our answers and where decimal points should be placed. See you in class.